Okay, so next up, the table shows values of x and y. Show that these values fit the relationship that y is inversely proportional to x. Root x, sorry. So we can write that as y equals k root x, and then we're going to have to calculate the value of k. I'm going to take two of my paired up things. I'm going to say that 6 equals, that should be k over root x. So I'm going to say that 6 equals k over root 4. So 6 equals k over 2. So 12 equals k. We can now write a formula that will work for all of these problems, or should do anyway, which is y equals 12 over root x. If we substitute into this our second pair of values, then two sides should be equal to each other. So we are going to say that 3 equals 12 over root 16 equals 12 over 4, which is 3. Perfect. And then the last one is 2 equals 12 over root 36, which is 12 over 6, which is 2. Perfect. We've shown that it works. Next part, A is inversely proportional to B squared. When A is 3.75 and B is 4, find a formula linking A and B. So we're going to have to work out what K is again, and this time that's as far as we're going to need to go. So y equals k over b squared. Substitute our values in. 3.75 equals k over 4 squared. 4 squared is obviously 16, so 3.75 times 16 is going to be k. K is 60. So that means that our formula is going to be this, but with k substituted for 60. A equals 60 over b squared. Right, I showed that question, so we've got to do each bit, make it blatantly obvious what we're doing. So I'm going to do the a to the power of 3 all to the power of minus a third. Let's just deal with that bit first of all. If we've got a power inside and a power outside, we multiply them. 3 times minus 3, we're going to end up with a to the power of minus 1. If we do the same with a squared all to the power of a half, 2 times a half, a equals 1 this time. So we are multiplying these two things together. So now we're doing a to the minus 1 times a to the 1. When we multiply two things like this, we add the powers, we get a to the power of 0. Anything to the power of 0 is 1. Next up, we've got to region R satisfies these inequalities. Y is greater than 3. I'm going to plot that on my graph straight off. I'm going to imagine it's y is equal to 3. So there we go. We're going to draw the line where y equals 3. But because it's greater than but not equal to, it's going to be a dashed line. And we want everything above it, so I'm going to shade out the bit I don't want. Next one, y is greater than or equal to x. So we're going to plot the y equals x. So when y is 1, x is 1, when y is 2, x is 2, etc., etc., we'll get a diagonal line. Yep. There we go. It's a solid line this time because it can be equal to it, and we want everything this side of it, everything that's greater. Again, I'm going to shade the side I don't want. And finally, we need to do x plus y is less than or equal to 9. I'm going to think what the line x plus y equals 9 looks like. We're going to need to get 2 points. If x was 0, y would be 9. And if y was 0, x would be 9. Join those 2 points. It's going to be a solid line again because it's less than or equal to. And I'm going to shade the side I don't want again. Which means that the region I do want is this bit here. Because I haven't shaded this side or this side or this side of the line. Which takes us to our last question on the paper. Solve this equation algebraically, give your solution correct to 2 decimal places. Alarm bells should be ringing. We're using the quadratic formula because it's to 2 decimal places. We've got a coefficient of x squared. It's going to be, unless it's told us to do otherwise, we're going to use the quadratic formula, which is minus b plus or minus the square root of b squared, minus 4ac, my bright mind here, all over 2a. Now, there are going to be, let's work out what a, b and c are. A, b, c. A is the coefficient of x squared, so it's 3. B is the coefficient of x, so it's 8. And c is our constant, so it's minus 5. We are now going to substitute these into here. There are going to be 2 solutions, one where we've got a plus here and one where we've got a minus here. So, first solution, we're going to have minus b plus, minus 8, because b is 8, plus 8 squared minus 4 times 3 times minus 5, all square rooted, divided by 2 times 3. That's going to equal something. My second solution is going to look identical, except there's going to be a subtraction here. So we're going to have minus 8 minus the square root of 8 squared minus 4 times 3 times minus 5, all over 2 times 3. Now, we'll go for our first solution first. So fraction button, minus 8 plus, then square root, 8 squared minus 4 times 3 times minus 5, then 2 times 3 at the bottom. If we hit equals, it's given us a surd as an answer. We don't want a surd, we want a decimal, so the SD button, and that's minus 0.19072423333. I'm going to round that to 2 decimal places, so that means that I want that chunk there. And so when rounded, that's going to be minus 0.19. That's just not right. What have I done wrong? That's what I've done wrong. Times. That looks more like it. So it's going to be 0.522588, etc., etc. So actually my first answer is going to be 0.52, because they are my first 2 decimal places and the 2 rounds down. Now, second answer, we're going to change this plus to the minus. Again, we want it as a decimal, and we're going to get minus 3.189254788, etc. And we are going to round that again to 2 decimal places. Whoops. So there's our second decimal place, and then we've got a 9, so we're going to round up, and that's going to become minus 3.19. Yeah, sorry about that mistake. Easily corrected though.